So today we'll cover IPSec protocol, and we discussed about this protocol in the last class. We also try to design it, right? I mean, how actually it works. I mean, suppose you are given task to design an internet layer 3 protocol, which works on top of layer 3. However, it uses that is secure, okay, end to end. Now here we are not talking one router to another router security, but it's a kind of end-to-end. So basically, if there are two routers at two ends, like your end, there's one gateway and there is a gateway at the other end. So we should be able to run some protocol such that almost all the data packets, depending on security need, will use IPSec. Okay. All right. So it's very complex protocol. It's extremely complex protocol. And not many books really cover it, and the draft of this must be more than few hundred pages long, and it's very comprehensive. It means it has a lot of variations and lot of different protocols it can use internally, right? So you'll find it extremely complex, but don't worry about it. Just try to get the gist how it works, right? And then whenever you have time, if you want, you can go through it. So I've taken it from these many sources. Of course, these three primary sources I have used in the book. Okay, these are the contents. I will be little quick and try to give the basic concept. Don't go into too much of bits and bytes that are written in the presentation. I will just try to explain you flow. Once you understand the flow, if you want, you can go into details. So we see that this works at network layer. Before that, we have seen protocol that work at data link layer, right? Between these two, for example, for each link. Okay. While here we say that it's a, let's assume these are all routers. Okay. Routers, of course, will have switches inside. But this protocol will run between the first gateway and the last gateway, or router. When we say gateway, is nothing but a router. Okay. All right. So just give me a minute. Give me a minute. Okay. My iPad has. Oh, sorry. Okay. All right. So let's go on. So it's basically works at network layer. Can you please mute? Somebody is not mute, and I can see somebody is in kitchen. Okay, I will mute all. Okay, all right. All right, so it works at network layer. It means that between your router and the end router. Okay, it's basically end to end, or it can work between your laptop. Okay, and from your laptop you can create IPsec tunnel to the gateway here. Right? So it essentially before exiting. So, or it could be if your other laptop is also capable of handling, then it could also go to other laptop, right? So usually it's between one gateway to another gateway, or from one laptop to the gateway. Okay, now sometimes it's really confusing, right? So note that IPsec, we are talking that it works at layer 3. Okay, and then there we have SSL, which works on transport layer, and then HTTPS, which works at application layer, right? Okay, so now it means that we call it layer 3.5 because it uses IP. It means that you are going to use IP packet. Okay, now IP packet, now you need to, here it means that, see, your application may be giving this, okay, and but you need to modify it. Sorry, so application data may be coming from here. So and this is the original data that you may want to send. Now there must be some fields corresponding to IPsec. Okay, so that it can take encryption data and authentication data. So we create some extra field in the format of, like for TCP we have field, right? TCP packet goes inside IP packet. Okay, here TCP packet, if that application wants to use IPsec, will go inside IPsec packet, and that IPsec packet will go inside IP packet, right? So we'll see how it can be done. It can be little overwhelming. Okay, just right now you just think that is layer 3.5. So all applications automatically use, whether they like it or not, if IPsec is there, right? So application layer don't have to change anything, right? So so whether IPsec is being used or not, they don't have to worry about it. Only at the OS level, some insertion of extra field can happen. All right. Okay, so IPsec provides a capability to secure communication across LANs or public WANs and the internet. So just think of use of VPN. Now VPN, that you would have got a VPN client, and there's another there is other end, which is the server, right? When you connect to IIT Goa from your home, you use VPN so that you get your data that you are sending get secured. Okay, and anything that at that point in time you are sending is going through that VPN. All right. So basically it creates a tunnel for you. Okay, so IPsec, the main use of IPsec is VPN. So that's exactly what we'll do. Okay, so what the main feature of IPsec, that it can encrypt and authenticate all traffic at IP level. When we say encrypt, means that we are using regular encryption, symmetric key encryption, and authenticate means that actually the server at the other end, IIT Goa, will come to know that packets are coming from you and only you. Okay, for that connection. All right, so these are only two things that it does. It encrypts and it authenticates. Now, sounds so simple, right? Then why is it so complex, right? Now complexity comes because the question is that your machine, okay, and the server here, they have to, this, your machine can have only certain number of encryption protocol, right? Like DES, AES, and some others, and these protocols will there, and authentication methods could also be different, like this could be HMAC or something else, or simple hash or okay, that could also be different, right? So there is a variety here and variety for encryption protocol, and then server has to also support that. Okay, so it means that there are number of protocols that can be used for encryption and authentication. Okay, and there is, of course, has to be choice whether you want to do both encryption or authentication, either encryption or authentication or both. Now that causes a lot of complexity. Okay, now in order to do encryption, you need to both ends, and it's a streaming encryption. Your data stream, and you have to go to other end. Data, encrypted data has to go to other end. So basically, both ends have got to have symmetric key or shared key. Now shared key is also to be created. Now creation of shared key is very expensive process, right? you have to choose a random number, like exponential number, what a raised power and something, we have studied it, right? So even that process of creating a kind of pseudo random number, and then key exchanges, etc., is extremely time consuming. It's a costly, right? So it has to be done only few times, and then we'll have to do it intelligently so that once it's done, then it should be that key, shared key, session key, in some form or other, or we should some create some modification of over that, should be used for sufficiently long time. See, if, there is also concept the same session key cannot be used for hours. Okay, suppose you have created a VPN connection, and initially session key is created. Okay, that session key, is not going to be used for 2 hours. You are connected over VPN, so this session key has to be, modified or remade. Wow. Okay, my house is close to old airport in Bangalore, so this kind of military plane that's going through. It happens sometimes in the morning. All right. So there are a lot of combinations that are possible, right? So that's so basically there are 3 things that protocol takes care of: authentication. Now it's a packet by packet authentication. Every packet that leaves your laptop has to be authenticated at server in IT Goa. Okay, it means that your packet should carry some information apart from normal text to other end. Like it's nothing but, say for example, we have studied HMAC or hashed MAC, right, or message authentication code. Of course, when we say HMAC, that will also use a key. Okay, that will be available on both sides. So again, all these keys that are to be used have to be generated. Okay, all right, and then we will have to also authenticate. We may also use private key and public key. Okay, because non-repudiation can also come by digital signature. So then we'll have to also create public key and private key. So there are a lot of key generation that happens and exchange of these keys, and based on that, some security associations are formed. Like the moment you log in and then to VPN, you start using VPN, there is a security association that will be formed for you. That will specify, when we say security association, that will specify a lot of things, like your ID. For your ID, what kind of crypto you are using, what is the time stamp, and many other things, right, can be there in that security association. That security association is there between your machine, your laptop, for that connection, VPN connection, okay, to the server. Okay, so now you restart sorry, so in a system, there not necessarily there will be only one security association. If you have multiple VPN sessions, then you can have multiple security associations. We'll come to security association little later. Okay, all right, so let's go back, and then we'll see that authentication is one way, one requirement. Confidentiality is another. Authentication requires what? Authentication and integrity requires some mechanism, right? Like HMAC, we have studied this. Signature, digital signature. Okay, now, and also it requires whether your public key or Bob's public key is not misused. Okay, you also need certificates. All right, so now not necessarily all applications may require all this, right? So that's the reason protocols also provides flexibility to do what do you want to do. So there are multiple ways the protocol can be used. One is not single protocol, also there are multiple protocols. Okay, so first is authentication, second is confidentiality, third is key management, exchanges of so many keys that we have discussed, right? All right, okay, so these are the same thing. And encryption, we use encryption for confidentiality, hash HMAC for integrity, signature and certificate for authentication, repudiation including, and key distribution is a Diffie-Hellman algorithm. Now Diffie-Hellman algorithm also has multiple variants, multiple ways you can do, multiple algorithms, right? Okay, now we are not going to go into that kind of detail, right? All right, so this is one example. So we create VPN, say between these two entities, right? It could be end to end. Okay, now there is also a possibility that VPN is created between, for you, between regional office and main office. Okay, now, okay, not only for one user, but all users can also send the data through this tunnel, while this passes through public network or internet. Okay, so basically you create a tunnel here, and any user may send it data through this one to other end. Okay, so there are a number of ways is possible, right? Suppose you are a mobile worker, you are in a hotel, and there you, from where there you are working, so then there is a need for a VPN to this ending not on the Wi-Fi router there, but is ending on your laptop up to this point. Okay, so all these possibilities are there. So now in this diagram you see that suppose your laptop, you're connected, you're in hotel, you're connected to Wi-Fi, then your machine laptop should create IPSec connection, right? Okay, or send data over IPSec. So you can see that your laptop is now generating traffic or packet, or created a packet that has additional field called IPSec header. So you have IP and normal IP header, and then payload or data, and then IPSec header, and it will go here over internet, and then this router, which is IPSec aware, okay, can remove this IPSec after checking, decrypting and checking HMAC or whatever, right, for integrity, and convert this to ordinary IP packet, and it can go to any machine, server, and so on. All right. Okay. Now you can see this in another direction also, right? Suppose the laptop is inside a corporate network, and it does not really it's not generating IP packet, right? So this packet is generated by the machine here, is generating this packet, which is ordinary IP packet. Okay, and then now this is IPsec router or gateway, and the tunnel is only between gateway to gateway. So then it will create IPsec packet, which will go over net, and it will come to this gateway, and will remove that after doing authentication check and decrypting, and send the original IP packet to wherever. Okay, any question? All right. So this is another view. Okay, host is just, let's assume that any host or any machine or laptop creates ordinary IP packet. So this is ordinary IP packet. Okay, but the moment it goes through gateway, and then gateway is connected to internet, then it will create a packet here. Okay, which will be where this packet will go inside another packet, and it will be encrypted, and then another header will be added here. Okay, so then this packet goes over internet, and when it reaches here, all these things are remove decrypted authentication check will happen, and this original packet is recreated and given to the host. Okay, so basically gateway can put extra fields. Now extra fields are of different types. I mean, what we have seen is two types so far, right? I mean, of course we'll focus only on one type. There are multiple types, right? Because if you want only authentication, then field will be different. If you want only encryption, this field will be different, right? This extra field that we are adding, for example, here. And if authentication and encryption, then it will be very similar to the one for encryption, right? So basically, we see there are three possibilities. All right, all right. Okay, I will skip this. So let's get into architecture, right? So basically, we'll give you very brief how does it work. Okay. All right. Suppose you have a laptop here, and there is a gateway. Okay, or your Wi-Fi router is working as a gateway, and there is a internet in between. So now your router, and this is your institute gateway. Okay, this is your Wi-Fi router or Wi-Fi router gateway. Okay, now you're doing a lot of things. You are doing Googling also, right? Or you have some traffic that can go anywhere else apart from your institute, right? So there is some traffic that's going somewhere else. There is a traffic also going to server which is inside the campus. Okay, then this gateway has to decide the packets that are coming from your laptop, that some are meant to go outside, and then in that case there is no need for IPSec. Okay, so it will let packets go as it is, and then there are some packets which needs to go to here to certain destination will have IPSec, right? So it means that this gateway should have some policy database, and that database will look at certain parameters like who is user, what is ID, same, even say MAC ID or hardware ID, what is IP address, what is destination address, and so on, right? So, and based on this, it can take decision. So it means that there has to be a table which we call it policy database. Okay, now this first thing. So your packet first, your gateway will look at policy database and say, yeah, your packet is going to IIT Goa server, and then it needs IP security. Now, next question is that how do you secure it? There must be some understanding between your machine. There must some understanding between the router here and the router here. Okay, and it is and there may be many laptops connected here. So what is the understanding for your laptop? Okay, so that and what kind of for your connection or your data that's going passing through, which you call logical connection, what all is required, what kind of crypto you are using. Okay, whether you need only crypto means that AES, DES, whatever. Okay, what kind of certificates you are using. Okay, so all okay, and all this understanding is unique to logical connection that you are having to other end. Okay, so that all these data which we call as security association. For your logical connection, we call SA. Okay, so now the moment it looks at policy database, it will from the database you will find out what kind of security association you have. You means that based on your MAC or IP address or destination, right? And then your that kind of processing will be done to your IP packet, because your machine has sent IP packet. Then from security association, you will find out you are using AES. Okay, then AES means that we have to encrypt this part. The question is, where is the key? A key would have generated, it would have kept somewhere. So it will also be part of this association information, right? Okay, and then it will decide also I have got to do authentication, right? So there is some info that how your header here will have HMAC data, because you will find out MAC for this and put it somewhere. Okay, and when this packet is saved, the other end can be authenticated, right? So all this processing is done by gateway or VPN server here, uh, you know, to the packet based on this security association. Okay, and other end, when your packet is received, that security association information is available in the packet. It will look at the database and do the decryption and authentication. Okay, so it means that the security association is part of negotiation right in the beginning. So they will decide, both ends will decide, like your machine or your server, gateway server, and other server will decide what are the cryptos, what are, what's the authentication method, and so on and so forth. And this understanding with security association will be there. Okay, so now this security association is one directional. Okay, so we're having communication both direction. There will be two security association. Here this is sender first case, is a receiver, and then from receiver, then this becomes sender in second case, and packet are going in different direction, and so on. Okay, so this is the basic concept. Okay, rest is about what is the format of this packet, whether you're doing encryption, whether we are doing authentication, or combination of both. Okay, hence you'll see so many combinations. Now there are two modes of propagation. First is transport, second is tunnel. Now transport is okay, the case that we have studied now, that there's a gateway here, and there can be multiple ordinary users with laptop who can't do IPSec, right? So now this gateway is IPSec aware, this gateway is another IPSec aware. So this tunnel that's created through encryption and authentication, primarily encryption, is between these two gateways, and this ordinary IP packet comes here, and then this gateway does encryption and authentication, and then send it here on the channel, right? So this is called tunnel way. Okay, while transport way says that your laptop is capable of doing IPsec, right? So you modify, so in your packet, IP packet, you modify the header. You have IP header and then put IPsec header, and then so this becomes then end to end, right? It does not have a major role of gateway here, but the packet creation, IPsec packet creation happens on your laptop or end machine. Okay, now these are the two ways, okay, which is called okay, transport mode and tunnel mode. And then we may want header of this packet to be either do encryption or authentication. Okay. Now, when you do encryption, there is also an option here that you just want plain encryption or encryption with authentication. While there is other option where AH or authentication database says only authentication is required. So many applications may want only authentication, not necessarily encryption. But something that is very popular is, of course, with encryption and authentication combined. So most of the VPNs, when you use VPN, then you see what is it doing. Note that VPN technology is still not totally, what do you call that, mature. You cannot use VPN client of some other company. I mean, normally the server and the clients are made by same company, right? Because there is so much of variation in protocols. Now, if you buy a public VPN, right, and yeah, a lot of public VPNs are available, right? So then many free VPNs, if you see, what they do is just authentication. They don't do encryption. Okay, while paid ones, of course, do encryption as well. All right. So this diagram shows what are the protocols we are going to use here. Like for key exchanges, like because we have to create different keys, session key, and so on, right? So we use Diffie-Hellman and various types of Diffie-Hellman, where DH stands for Diffie-Hellman. Remember, through Diffie-Hellman, we create a session key, right? Okay, and then authentication is use of MAC or MD5. Is basically these are hash algorithm, right? Now these hashes are used along with like in the form of message authentication code, MAX. And then streaming encryption you use using DES or 3DES or AES. And then you use basically the protocols that we are going to use either for encryption or encryption and authentication or only authentication. So these all defines different protocols that we are going to use. Is it confusing? Okay. All right. So it may sound confusing. Please go to the slide sets. So basically, we just now discussed that we can either use ESP, which is encryption, encapsulating security protocol, or authentication, right? So encapsulating security protocol can do encryption. Usually, the important function encryption, or it can also do encryption plus authentication. Well, AH can only do this kind of headers, can only do authentication. Okay, so these are the two. Now this diagram shows something that we have already discussed. Okay, we have security policy database. So when a packet comes, module has to look at security policy, whether what kind of policies are applied, whether what kind of encryption etc are to be used, or encryption is to be used or not. And then it gives the index of security association for that logical connection. Okay, so it means now through this policy database we come to a security association database, and we see if the data is going to IIT Goa, then what kind of encryptions are to be used and so on and so forth based on security association. Okay, or that temporary relationship with that end with respect to security. And then we have key exchange protocols. Okay, that's all in the protocol, right? So first is that security association. We have already studied this. Okay, so what security association will be there? Just a minute, let me see. Security association for connection to say R2, which may be in ITG, will contain the following. Okay, it will contain the IP address here. Okay, and it will also contain destination IP address, like IP address of this router. Okay, what kind of encryption to be used? For example, DES with CBC. What is the encryption key? Whether is HMAC, what kind of integrity check, what is authentication key, and what kind of protocol you're using, whether ESP, what is the lifetime, and so on, right? So now this defines a security association for a logical connection. All right. Okay. So when you when you connect the VPN to VPN server in IT Goa, then all these things are to be there to define that security association. Okay, and all this data is there in an entry in the security association database in this server, and then all these things are there in one entry, so there has to be one index. Okay, all right. So this index will come to know through security policy database. When your packet comes, it will look at it, your packet details, and then decide. It will tell that, okay, there is already relationship, and this is the index. In index, all these things can be found out. What kind of authentication is to be used, and so on. And all this information is also there in the R2, and so on, right? Okay. So we have covered all this. So index is called SPI in this database, security parameter index. All right. So this, please go through this. Okay, so security association generally consists of what all we have seen here, which is security parameter index, because this index will give you this index will tell you about all this, right? Okay, and then destination IP address and what kind of protocol we are using, say ESP or AH. So this gives overall security association. All right. Okay. So all these things we have already discussed, right? So now this is a security association database. Okay. Now so a packet comes, IP packet comes, and then it turns out that you'll have to use, say, is for Bob, and then you'll have to use basically Bob's SPI is 17. Same security association has to be there at both ends. Okay, because same crypto are to be used. Same authentication protocol is to be used, right? So however, in table there can be different entries. Okay, because it's not synchronized table. I mean, same entry has to be there, but entry number could be different, right? So this Bob's SPI has to be included in the packet such that Bob knows that how to decrypt it. Okay, and this security association will have lot of other parameters which are not shown, which what we have discussed here. Okay, like all these will be there in SA as part of SA. All right. So this just simply shows that this kind of table, security and association database has got to be there at both ends. Okay, and this again shows the same thing, that through security policy database we come to security association database. We look at the details, what kind of crypto etc we use on packet by packet basis, and then transmit to other end. All right, any question? All right, please go through it. It's little confusing. Okay, so same thing is depicted here. This outbound packet, so A is sending it to B. Okay, IP packet comes in. So in security policy database, it is to be checked whether it is for IPSec. If so, which policy entry to select, right? Okay, so now it will find out what policy is to be used, and this from this will get the index of security association. So it's for IT Goa, for example. Then a particular security association is checked because is to be found out because a particular set of crypto etc are to be used, right? So now you select this one, for example, based on this index, and then you'll find out what are the cryptos and so on and so forth. So IPSec processing can be done, and you find out, and then in the packet you also include SPI of Bob. So this index which Bob's informs as part of negotiation, so you put it here and then send the packet. So Bob knows what kind of, will look into his own security associated database and then do the processing. All right. And this is inbound processing. If it means that now packet has come from A to B. It has already SPI available. Okay, security policy, security association. Oh. Okay, it has already this index available. Okay, so you look at the security association database and then get the details. It means that now Bob's machine knows how to process it. Okay, because all crypto details etc are there, and then from there it can go get more details from security policy database, and then decrypt and find out or can create original IP packet. All right, any question? So what we have explained so far is a flow that various databases are there. One is a policy database, and then another is an association database. Association database tells you the temporal relationship between sender and the receiver, what kind of cryptos are to be used and what is encryption method, whether we are using encryption method or not. All these details are there. What is the key, what are the keys, what is the key length, etc. All of them are there in database. But note that the packet only contains the index. So when Alice is sending this packet, only index of Bob's security association or index that can give security association for Bob's machine is included in the packet. So anybody who actually sees the packet cannot find this out. Okay, now we have seen that there are two protocols. We don't of course have time to discuss even one. Till another 10 minutes we'll go through ESP. AH I will the slides at the end which you can read it by yourself. Now ESP is encapsulated security protocol which provides authentication and basic integrity and confidentiality. It means that we are using both encryption of the packet and also authentication, which means that MAC or HMAC. Or authentication can also be through digital signature or whatever. Okay, totally depends on what protocol you use, right? Okay, so it may support a large number of protocols, and as part of negotiation in the beginning when security associations are formed, it will decide which one of these will be used. For example, it may use DES. And in the packet that we create, now note that in IP packet there is something called type of protocol field is there, right? What kind of protocol is getting inside, okay? For TCP there is one number, UDP there is one number. Similarly here we are using protocol number 50 as a type of protocol. Now the moment router sees that there is a protocol number 50, it has to handle it differently. So now we'll look at that, right? Okay, so this is the ESP protocol, encapsulating kind of protocol. Note that this is original IP packet. Sorry, this one. So this is original IP header, this is original datagram packet. So you take IP packet that has come and then encapsulate this in another IP packet. Okay, and add an extra field. So this is a new IP header. New IP header field is here, and then another extra field you put it here, which corresponds to this protocol, right? Which we'll call a ESP header. Okay. Now this ESP header has to contain certain information, which it has to know that what recipient has to know what kind of cryptos are to be used, whether it's authentication protocol, whether authentication is used. So all this information comes from SPI. Okay, the index of Security Association database, right? Okay, like the one which we have seen here, anyway, SPI here. Okay, all right. Okay, all right, and of course sequence number. Sequence number, we try to create sequence number internally to avoid a kind of attack called replay attack. Okay, and then at the end you have authentication, right? I mean, you calculate MAC, HMAC, etc., and put the data here. All right. So now your protocol, what all is protected? Your original, this thing is encrypted. So there is a confidentiality. Okay. Now ESP trailer, which header is here and trailer is there. That has padding, pad length, next header, etc. Is also encrypted. All right. So and then this authentication field will contain data corresponding to authentication, or when we calculate MAC or HMAC over certain area, right? So all this is included in that. Okay, so all this is now protected in either by encryption or authentication. However, this remains in plain text. All right. So there is still, somebody is Trudy or Mallory is checking all the data, all the packets. They can still find out some traffic is going somewhere, but not more than that. All right. Any question? I wish I could create some kind of simulation here because it's kind of complex. Okay. So what we have done now, we have seen one kind of protocol header, packet header, which here, which ESP type, through which we can do encryption using some protocol and authentication, like ESP authentication. Now this authentication is of course not necessary. Okay, so there is option. Okay, so now we have already seen tunnel and transport type. So tunnel of course happens between gateway to gateway, and transport happens between end entities. All right. So now this is the way we create tunnel. Take original packet, put it here, then have IPSec header and new IPSec header, right? Okay, so this is firewall to firewall traffic. Okay, all right. This is another view. So Alice is sending connected to firewall or gateway. So there is no IPSec between two entities here, between release and gateway. Similarly, Bob and gateway, there is nothing. However, in between there is a tunnel. All right. Okay. So moment packet comes here, gateway does all encryption, right? Using ESP or AH. So this is where what it is. Okay, so it's something like this. In case of tunneling, Alice sending something, she creates a packet P1. This is ordinary IP packet, and then gateway creates encapsulates it another packet and sends it to now. After encapsulation, the IP destination IP address here in added IP header, because original IP packet is here, will be that of a gateway G2. Okay, so once gateway G2 receives this, removes and does all processing and removes and gets the original IP packet back, it looks at the destination and sends it to Bob. So original IP packet then goes to Bob. Okay, all right. Well, this is what we call is tunnel mode. Okay, this is what. So we have seen ESP protocol working with tunnel mode, and this is the format. Earlier also we discussed the same thing. Okay, now if you look at how in actually how the inner packet, right, the original packet gets encapsulated is seen here, right? So this is the original packet. Okay, the original packet, now note that is coming here. Okay, so look at this field. Within IP packet also there is a TCP packet, and then here the protocol field here defines the TCP. Now there is a number corresponding to TCP. Okay, all right. So now okay, now this header inside will contain the IP header will contain this data, which will show that something encapsulated is TCP. But note that this is added header, right? This additional field that we are adding because we are encapsulating one packet another. Here, this field, protocol field, shows ESP. Okay, such that now receiving gateway knows that it's in encapsulation is ESP kind of packet is received, and it has to do processing, and it will then look at various fields in that, for example SPI, etc., and then process the packet. All right. Okay, because as part of ESP header, okay, SPI goes, right. So receiving end will know how to process it. Okay, all right. Wow. Okay, so what we have studied is ESP method. Similarly, we have transport method, which of course you can go through if you want. And then we have internet key exchanges. So we'll right now I will stop here. In the next class, we'll discuss in brief what we have discussed, and then look at internet key exchange protocol, which is nothing but it's very quite simple. We'll not go into details because what we have done studied is so far using Diffie-Hellman and asymmetric key encryption. We can always exchange the keys. Okay, that's all is given in this protocol. So we'll study in the next class some details of IKE. Okay, any questions? It looks quite overwhelming, it's quite complex. Okay, but remember just few simple flow that the packet coming from your laptop needs to be encrypted. It needs to have something for other end to authenticate. So you have to add information corresponding to that, and other end should know what kind of cryptos are to be used, how to authenticate. So this extra thing that you're adding to IP packet, it should be very clear. That's it. And in order to do that, you need lots of keys, session key and other keys, and that also has to be that information also has to be available in some kind of, like we call it SPI or some kind of database, right? All right. Okay, thank you. Any question?